All right, so in the last lesson, we had equations with brackets in which everything inside the brackets was being multiplied by something. In this case, we'll have, for example, there's no brackets here, but you can imagine there being brackets in the numerators, in which everything inside the brackets is being divided by something. And again, I'll look at two different ways of approaching this, and ideally both make sense. So let's focus on this exact same equation twice. Let's look at this one. So one approach right off the bat is, again, it's not wrong to put brackets around here, is to build on something we saw before. Right now I have a minus 6 being divided by 4. It'd be kind of nice if that division by 4 was not there, so I can cancel that out if I just multiply both sides by 4. And I can just see those cancel each other out. And so, and it's not a surprise they cancel each other out. That's the whole purpose of me multiplying both sides by 4. So I get a minus 6 on one side and 28 on the other. And then add 6 to both sides, and I'm done. A equals 34. All right, so I know my answer. Let me just mention another way of looking at it, although that was pretty quick. So the exact same equation here again. And again, I'll put, I could put brackets around there. But another approach, which is also builds upon things we've done before, is I could think of a minus 6 being divided by 4 as being a divided by 4 minus 6 divided by 4. Think of it as two separate fractions. So a over 4, take away 6 over 4. Okay, if I do that, I no longer have this big fraction. And there's a few things I could do. I could reduce the fraction of 6 over 4. 6 over 4 does reduce to 3 over 2. However,
Mr. Kelly, please call 3201. Mr. Kelly, call 3201.
All right. Or however, though, I still have these denominators of 4, which we saw from an earlier lesson. I can cancel out right away if I just multiply everything by 4. So I'm going to multiply everything by 4 right away at this point. And so if I do that, I have 4 times a over 4. The 4 is going to cancel out. I just have 1a left. Over here, I have 4 times 6 over 4. The 4 is going to cancel out. I just have the minus 6 left. On the right-hand side, I have 28. That's the hardest step done. Now add 6 to both sides. And again, I got the same answers before. So by looking at this, if one looks easier than the other, fair enough. That is, again, a matter of opinion. Ideally, both make sense. I can either multiply both sides by the denominator, or I could break up those multiple terms all being divided by 4 as two separate fractions. And so with that said, let's just solve this one way. So many ways we can approach this. The more we learn and the more complex equations get, the more and more options that hopefully become apparent to us. For this, though, I'm going to distribute the 2/3 right away. Although I'm very aware of other things I could do. I'm going to distribute the 2/3 right away. So I have 2/3 times b is just 2/3 b, plus 2/3 times 4 is 8/3. Again, 2 times 4, 3 times 1, if you imagine there being a little 1 underneath here, however you want to look at it. And this equals 5/6. OK. So now I have some denominators here. I'd like to get rid of these denominators. And we saw before, if I just multiply everything by the lowest common denominator, I can cancel out these denominators right away. And so the lowest common denominator of 3 and 6 is 6. So I'm going to multiply both sides by 6. So on the left-hand side, if I go 6 times 2/3, well, again, there's various approaches, but I could look at it, if I think about what is 6 times 2/3, I would recommend just realizing, well, 6 over 3 reduces to 2 over 1. So I have 2 times 2, which is 4. Or you could, if I write 6 times 2/3, you could literally just go 6 times 2 is 12, 1 times 3 is 3, and then to reduce this down to 4 whole. Either way, 6 times 2/3 is 4. And so 6 times 2/3 b is 4b. And then similarly, 6 times 8/3. However you want to approach it. I would think about it like this, as 6 times 8 over 3. 6 over 3 again reduces to 2 over 1. 2 times 8 is 16. So I have plus 16 here. Lots of approaches, but in the end, if I multiply both sides by 6, the left-hand side is now just 4b plus 16. The right-hand side, I can see pretty quickly these 6's cancel out, is just 5. And I like that equation a lot better than what I see before. I just have 4b plus 16 equals 5. And now this should be quite quick. I'm going to subtract 16 from both sides. So 4b equals 5, take away 16 is negative 11. And then lastly is just divide both sides by 4. And again, you probably want to decimalize it. 11 divided by 4 is 2.75, so this is negative 2.75. So definitely getting, compare this to just a few lessons ago, definitely getting more involved. And there's another option I could have done from the start. From the very start, I could have multiplied both sides by the lowest common denominator right away. I could have decimalized some of these things, although the decimal of 2/3 is 0.6 repeating, so that's a bit awkward to work with. Lots of approaches, definitely getting more involved. But I didn't need to decimalize anything. Even at the end, I could have left it as a fraction.